Okay, so today we're going to be talking about section 1.2 in your book, and we're going to divide this into a two-part lesson because I started doing a video on this for one part, and it just got to be so long that I thought I would break it down into two sections. Excuse me. None of this information should be too new to you in this part of the video, and we're dealing with graphs of equations. One of the first things we're going to talk about is how we would determine solution points. So determining solution points, which means solution points. And what it means to determine a solution point is to find if a point actually lies on the graph of an equation. So if we were asked to determine whether 213 lies on the graph, make sure we get all that in there, lies on the graph of, say, y equals 10x minus 7. The way we would determine whether this point would lie on the graph of this equation would be to plug in our x, y values, this being our x and this being our y value, into x and y in the equation and to see if the outcome is true. All right. So if I were going to plug in 213, the xy coordinates 213, into this equation, I would go, well, I have y equals, and y is 13. So 13 equals 10 times x. I always put a value in parentheses, especially if it's being multiplied, so that we could show the multiplication, times 2 minus 7. And then we can go ahead and solve this. And if the statement that we get at the end is true, then that point would lie on the graph of y equals 10x minus 7. So here I'm just going to rewrite 13 equals 10 times 2 is 20 minus 7. And clearly we can go 13 equals 20 minus 7, which is 13. And we know that this is true. Therefore, this point, 213, would lie on the graph of y equals 10x minus 7. What if I wanted to know if the point -1, -3 would lie on the graph of that equation? Well, this would be my x, and this would be my y. Now I would go ahead and do the same thing. In this case, my y value is -3, so I've got -3 equals 10 times -1 minus 7. And I'd go ahead and solve that, just like I did the other one. So I've got -3 equals 10 times -1, which is -10, minus 7. And I get -3 equals minus 17. That is not a true statement. -3 could never equal -17. And so this would be untrue, which means that the graph of this line is not going to go through the point -1, -3, unlike the other equation that we solved showed that the graph does clearly go through the point 213. And that's all we have to do to determine solution points. It's just plugging numbers in and seeing if they're true. The next thing we're going to talk about is the point plotting method of graphing. And really there's 4 steps to the point plotting method of graphing, and we'll write all of those down. So the point plotting method of graphing. So we get Number one, the first thing you want to do is whenever it's possible, you want to isolate one of the variables. What does that mean? It means get X or Y to one side, depending on what your variables are. I'm assuming they're X or Y. Get them by themselves. Right here in this equation, Y is a variable that is isolated, right? We're solving for Y. We could have made it X equals something, but when we solve for one of the variables, when we isolate one of the variables, it makes it so much easier for us to plot points. Number two, construct a table of values. So you've seen those tables a lot where we have the X and Y values and you can put in numbers for X and then plug them in and it'll tell you what Y is. You'll see examples of it in a second, but you guys have all done it before. Plot these points in a rectangular coordinate system. What is that? That's our XY graph. Coordinate system. And the last thing that we want to do is to connect the points with either a smooth curve or a line. Because when we're talking about equations, these connect because it'll go through those points, but it'll also go through all the points in between them. Or a line. Right? Those are the 4 steps in graphing by by plotting points. And we'll do an example of that. I'm going to get this piece of paper out of the way. But we'll refer back to those steps. So in our example, we'll be asked to sketch the graph of some equation, right? In this case, our equation will be 3x plus y equals 7, right? We need to sketch the graph of this equation. Well, if we go back to our previous page where we talked about it, the first step in doing so would be whenever possible to isolate one of the variables. So in this case, I'm going to want to isolate either that x or y. Y not having anything attached to it makes me think that it would be the easier one to isolate. So I'm going to go 3x plus y equals 7, just to rewrite it so you can see what I'm doing all the steps. Well, the only thing I have on that y right now is that 3x is added to it. So I'm going to subtract 3x from both sides of the equation. And I'm going to be left with y equals negative 3x plus 7. Right? I haven't changed the value of this equation at all. Remember, I can do anything I want to one side of an equation as long as I do it to the other side of the equation as well, and it doesn't affect the value of that equation. It's like one of the fundamental rules of algebra. So we've isolated the variable, and so now we can go to step 2, right, which says construct a table of values. You guys have seen this before, right? I'm just going to create a little t-table, right? Here I'm going to have x, and here I'm going to have y. what can I choose for x? Well, this is a line, so I know that the domain of x is all real numbers, right? There's nothing that x can't be in the realm of real numbers, right? So I can pick any values I want for x. Now, I don't want to go too big with these values because then I get huge answers, right? I get huge solutions for y. So I have a standard, unless there's a reason I can't use these numbers, like, you know, the variables in the denominator, so I couldn't use 0 or something like that. I usually try and always use -2, -1, 0, 1, and 2. Now, there is no rule of 5, but I personally have a rule of 5 when I'm doing these, where I always try and plot 5 points so that I can get a really good feel for what my graph is going to look like, right? That way I got a couple of negative numbers and I've got a couple of positive numbers. And how do I know what my y's are? Well, I just plug in these x values and I solve for them. And I'll show you a couple of them, but I'm not going to do all 5 numbers because you'll get the gist. I'll just plug them in. So here I've got x equals -2, so I go y equals, whoops, -3x, well, that's -2 plus 7. And I'm going to solve. -3 times -2 is 6 plus 7, which is 13. So I know that that one's going to be 13. Then I would do the same thing for -1, right? I can do it over here and go y equals -3x plus 7. But you'll get good at this. You could do this on scratch paper. This is not work you have to show, right? And I'm going to plug in -1. So I get -3 times -1 plus 7, right? Which gives me 3 plus 7, which is 10. So I know that this is 10. And I'm going to do that with all of the numbers in my solution set in my to match my x values. I'm not going to do all the work for it right now. I'm going to tell you that this 0 equals 7, which makes sense when you think about it, because if I make my x 0, this whole thing zeroes out and I just get y equals 7. Then 1 will equal 4 and 2 will equal 1. So I have all of these points, these x, y values. I've got 5 of them. And so now all I would have to do is make a graph. And I was going to do this on graph paper, but it was getting to be a pain in the butt. This is actually the second time I made this video. The first time I made it, the sound just didn't work for me. So I'm redoing it. I'm going to go low here because I know what this graph looks like in the end. So here I have an x-axis. That looks like a y, but it's an x. And here I have a y-axis, right? And I can put in my points 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I still didn't go high enough, 13, right? And here, this one's easy because I know my points, right? I've just got 0, 1, and 2, and -1 and 2. So I can go 1, 2, 3, -1, -2, -3, right? I know this is 13 up here, so we can number these. We can go 2, 4, 6, 8, 10, 12, right? Give us an idea of what our numbers look like. So when I go to plot these points, what do I have? I have -2, which is right here, and 13. So that's going to be a point right about there, right? My next point we've got is -1, 10. So at -1, I know I have a point right here at 10. Next point we have is 0, 7. Well, 0 is anything that's going to be on this y-axis, right? So my next point is going to be right here on y. Then I have 1, 4. What is that, right about there? And I have 2, 1. So that's plot the points. That was number 3 on our list of things to do. And the last thing on our list of things to do is to connect the points with a smooth curve or a line. Well, this is a straight line. Anything that doesn't have power to it greater than 1, we're going to be dealing with is a straight line. Now, my points are actually pretty good. I'm fairly impressed with me right there. And so that there is the graph of the equation 3x plus y equals 7. And that's how we use plotting points to sketch the graph of an equation. So, like I said earlier, when we did that one, we were sketching the graph of a power of 1, right? We don't have any exponents in this equation. 3x plus y equals 1. The degree of this equation is just 1. If you don't have any exponents, you're always going to be graphing a straight line. So we're going to look at an example where we're not graphing a straight line. So we're going to sketch the graph of, do another example. It's a much better pen. I should have been using this all along. Sketch the graph of y equals x squared minus 2. Now notice, whoops, if you can see it, notice that in this equation, we have a power. We have a square power on that x. So we will not be graphing a straight line this time. This is going to be a curved line, right? Those of you who may or may not remember that this is the graph of a quadratic equation, right? So this is our parabola. We better get a parabola. So I'm going to still follow the same thing, right? I'm going to follow those same rules that I did before. I am going to, for step 1, isolate one of the variables. Well, in this case, we already have y isolated, so that step is done for me. So I can move on to step 2, which is to construct a table of values. So here we're going to have our x and our y. And I'm going to use the same points I used last time. -2, -1, 0, 1, and 2. They're my favorite points. I use them all the time. When we plug those in, I don't know if you actually need me to plug them in for you. I'll do one and then you guys can do the rest of them, but I'll give you the solutions. So here I'm going to go y equals, oh, we have x squared, so that's going to be -2 squared. Remember to put the whole -2 in the parentheses because you're actually squaring the negative on this, right? Because it's not negative x -2. And then we can solve, well, -2 squared is 4 minus 2, which is 2, so that we know this is 2. I'm just going to go and fill in the rest of them. You guys, I think, can figure out how to plug numbers into the equations at this point. So we got -1, -2, -1, and 2. So I found all those points. The next thing I have to do is to plot all of them in that rectangular coordinate system. I like this one because our numbers are a little bit smaller. So should make it a little nicer on the graph. Here's my x, here is my y, right? None of my numbers on this table are bigger than 2, so I can make this graph kind of big. I can go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I can make them nice and big. 1, 2, 3. It's my favorite part. Not really. It's my least favorite part. I was lying to you. So there we've got a graph. Now all we have to do is plot all those points. So we can go, well, when x is -2, y is 2. So here I have a point. My next one is when x is -1, y is -1. So I have another point down here. When x is 0, y is -2. This is our vertex. When x is 1, y is -1. And when x is 2, y is 2. Now, I could have just done half of these and known the other half because I know that parabolas are symmetric. And once we found that vertex, some of you guys might remember that from Algebra 2. Then we connect it with a smooth curve and we have a parabola. I can tell you right now that anything that has an even, anytime you're having a square or to the fourth or to the sixth, you're going to get a symmetric graph, more than likely, whether it be symmetric about x or symmetric about y, it's going to be the same on both sides, right? I should be able to fold this piece of paper together on the y-axis and have those two sides meet up. So that is how you sketch a graph by plotting points. Then we're going to look at sketching a graph using the intercepts. And right now we're just going to go about finding the intercepts on the graph. Excuse me. Let's bring this next piece down. So we're going to talk about how to finding the intercepts on a graph. Right, intercepts of an equation. Finding the intercepts. Let's forget about on a graph for right now. The first thing we want to talk about is what intercepts are. And when we're looking at a graph, if we come back to this graph right here, our x-intercepts are where this graph of the line crosses the x-axis. So at this point, we would have an x-intercept right here, right? It's anywhere the graph of that line is going to cross the x-axis. Our y-intercept on this one, we already have the point, right? It is going to be at 0, 7. And when you think about that, think in terms of, well, if I have an x-intercept, what is my y on that point? My y is 0 because everything's on this line, right? It doesn't go up or down from the line, it's on the line. So we have a point for x, which would be 3, and a y would be 0. And so your x-intercept would be the point 3, 0. Your y-intercept on this, in the same respect, doesn't have an x value, right? Its x value is 0 because it's right on the line. And when we're talking about x points, it's distance from the line. So if the points on the line are distance from the line is 0, right? So our x would be 0 and our y would be 7, which is an important piece of information when we're talking about how to find the intercepts. So when we're finding the intercepts, we've got two of them, right? You have your x-intercept. So if we want to find the x-intercept, right, to find x-intercepts, you can set y equal to 0 and then solve for x, right? In the same respect, when you want to find the y-intercept, you're going to set x equal to 0 and solve for y. And again, the reason for that is if x is 0, our point is going to be on the y-axis, right? And that's what we're looking for, is points on the y-axis. If we're going to set y equal to 0, then our x values are going to lie right on the x-axis. And that's what we're looking for the x-intercepts, is points on the x-axis. So If I ask you, as an example, to find the intercepts of y equals x cubed minus 4x. Now this is an ugly problem, but it's not too bad, right? It's a fairly easily factorable problem. So the first thing I'm going to do is I am going to start with the x-intercept. Why? Because those are the instructions I have first on here. Doesn't matter which order I go in, but I'm going with x first, right? So I'm going to go x int, that's what I was calling, right? And what does it say to do to find the x-intercepts? Set y equal to 0 and solve for x. So in this case, I would have 0 equals 3x, oh, sorry, no 3x, x cubed minus 4x. And now I've got to solve for that x. I want to know what x equals, not what x cubed minus 4x equals, right? So I'm going to start by factoring, and I notice that each of these have an x in it. So I can factor that x out. Remember, this is nothing right there. All right, so I'm going to write this as if I take an x out of here, I'm left with x squared. And if I take an x out of here, I'm left with minus 4, right? You may or may not remember that x squared minus 4 is one of those special product patterns, right? It's the difference of squares. So I know I can break that down to x times x plus 2, x minus 2. And what do we know about this? Right now, what we know is that whole thing equals 0. And if you remember this from Algebra 2 and Algebra 1, is because these are multiplied, if any of these equals 0, the whole thing equals 0. It makes it true. So I can set each of these factors to 0, equal to 0, right? And find out what the different intercepts are, the different places where this equation would equal 0 and give us our intercepts, right? Our x-intercept, tell us where it's going to cross that x-axis. So I could go x equals 0. Well, that's 1. So we know at the point 0, 0, we have an x-intercept, right, at the origin. The other place that it's going to have 0 as well, x plus 2 equals 0. And we have to solve that for x. What is x going to be? So I'm going to subtract 2 from both sides, and I'm going to get x equals negative 2. So our other point is at negative 2, 0. All our y's are going to be 0 right now because we're looking for the x-intercept, and we have purposely set y equal to 0. We have one more, right? We have x minus 2 equals 0. So we're going to add 2 to both sides, and we will get x equals 2. So our point in this case will be 2 and 0. These 3 points are all x-intercepts for the equation y equals x cubed minus 4x. Now there are things I know, like I know that there can't be more than 3 intercepts because we have a power of 3 on that equation. So I can't have more intercepts than I have the degree of the equation itself. I would have to have 3 or less. So we found our x-intercepts. Here they are. There's 0, 0, negative 2, 0, and 2, 0. But the job is not done yet because it says to find all the intercepts. So now we also have to use the same equation to find the y-intercept, right? Now, in the same respect that we set y equals 0, solve for x to find the x-intercept, we're going to do the same thing to find the y-intercept. This time we're going to set x equal to 0 and solve for y. right? So here's our equation, right? We have y equals x cubed minus 4x. I'm just writing it down here so that you can still see it as we're working on it, right? So the last time we set y equal to 0 and solved for x, this time we're going to set x equal to 0 and solve for y. This is going to prove to be much easier this time, right? Because we're already set equal to y for 1. So I'm going to have 0 cubed minus 4 times 0, right? And so what are we trying to solve, right? We've set x equal to 0, and we want to know what the y point is. And all we have to do now is solve that. So we've got 0 cubed. Well, that's just 0. Minus 4 times 0. Well, anything times 0 is 0. So I have 0 minus 0, which just equals 0. So when we set all these x values equal to 0, our y also equals 0, which means that our y-intercept is the point 0, 0, right? Y-intercept, right? So it's at the origin. It shares space with the x-intercept, which kind of makes sense when you see a 0, 0 in the x-intercept, that the y-intercept is also going to be a 0, 0 because, well, both numbers are at the 0. So our x-intercepts are 0, 0, negative 2, 0, and 2, 0, right? And our y-intercept is the point 0, 0, right? That's all there is to it for, excuse me, y-intercepts. That's going to be it for this video for right now. The next video is going to have, we're going to talk about symmetry, and we're going to talk about the equation of circles, but this one's running a little long, so I'm going to end it here. Make sure you get that Edpuzzle done. I'll also be posting the video so that if you want to go back and watch examples, you don't have to sit through the entire Edpuzzle to do it. You can actually just fast forward through the video. So that is the end of part 1. Part 2 will be coming up very soon.